All right, my friends, this may have been a pretty weird little warm-up to give you, but let's see how far you got with it. Let's see. So you've got 4 items, and we're gonna pick groups of different size. So I think I'm gonna go ahead and start with size 2, and then I'll work my way out. So if you're grabbing these things in groups of size 2, then let's just list the groups. So you could have A, B, remember that's the same as BA. We wouldn't count switching the order of these two things as a different group in this case. Let's see, you could do BC, you could do CD. What else could we do? AC, AD, and BD. And I did that kind of in a weird way, but that is all I can think of for that. So we would say 6 ways. And I'm going to introduce some notation here as well. So basically we had 4 items and we were choosing combinations of size 2. Math notation for that is to say 4, that's a subscript. Combination, that's an uppercase C, like kind of normal, like if your blue line on your paper is right there, then that's just a normal uppercase C. And then subscript 2. So the way that we would read that is 4 combination 2 or 4 choose 2. Most people say 4 combination 2, and we would say 4 combination 2 is 6. We'll come back to this combination idea in a little bit. For now, I just want you to get used to the notation. All right, hopefully you got 6 for that. Size 3, let's see, you could have A, B, and C, A, B, and D, A, C, D, and B, C, D. And that's all I can come up with since order doesn't matter. And so we would say that if you have 4 items and you're choosing groups of size 3 where order doesn't change, the group, then there are 4 different ways to do that. All right, adding the math notation, we would say that 4 items, choosing combinations of size 3. Oops. So 4 combination 3 is 4. All right, let's do size 1 next. Size 1, you could choose A or B or C or D, and there are 4 ways to do that. And what combination would we call that? So we would call that 4 combination 1, and we would say 4 combination 1 is 4. Okay. How about groups of size 4? Let's do that one next. You could just choose them all, and there's pretty much only one way to do that. And we would say that that is 4 combination 4, and 4 combination 4 is equal to 1. All right. And then the size 0, I know it's kind of weird, but basically we would say there's one way to choose size 0. I suppose you could be rude or not. That's kind of 2 different ways. But size 0, you just have an empty list, just nothing there. And so we would say there's one way to do that. And then what combination would that be? That would be 4 choosing combinations of size 0. And so that's equal to 1. All right. Well, I was hoping, my friends, that you would see these numbers 1, 4, 6, 4, 1, and that would make you think about Pascal's triangle. And it turns out that we can actually write Pascal's triangle in terms of these combinations. And for the most part, that is not especially a good idea, but we'll come across some situations in these notes and in your problem set, and maybe a question on your test or 2, where you'll want to have this ability to do this. Anyway, so hopefully you feel comfortable with, seeing a little evidence of some Pascal's triangle magic in these combinations. And hopefully at this point, you're kind of comfortable with what I mean by the first subscript number is the size of the whole group. The second subscript number is the size of the subset that you were choosing. And then the number that you get for the answer is the different number of ways that you could have, that you could choose groups of that size. So, all right. So next, let's introduce a formula for combinations. So let's see, the combination formula. And if this was a probability class, I'd go into more detail, but it isn't. So I get to just kind of give you the formula. So the formula for N combination R. So N would be the total number of items you're choosing from, and R would be the subset or group size that you're choosing out of that bigger group. So it turns out you can calculate this with a fun little formula here. So it's equal to N factorial divided by N minus R factorial times R factorial. You're going to want to memorize that. Okay, now before we move on, let's just practice using it just a little bit, like a quick little illustration. If you were to follow this formula, just follow it, and do 4 combination 3. What would you get? So in this case, 4 is in the N location and 3 is in the R location. And so this would, on the right side, this would equal 4 factorial divided by 4 minus 3 factorial multiplied by 3 factorial. And then if we simplify it, we'd get 4 factorial over 1 factorial, which is just 1, times 3 factorial. And then the 4 factorial and the 3 factorial would cancel. And you'd end up with just 4. And that's adorable because in the warm-up, that's exactly what we got for 4 combination 3 when we actually went out through all the work to list them. Okay? All right, so between now and the next video, I'd like for you to play around with making this formula, preferably from memory. So even if you need to pause the video and memorize it, go ahead and kind of see what this formula would give you for 4 combination 2. And then practice maybe 4 combination 4. And yeah, we know what the answer should be, right? The answer for 4 combination 2 hopefully is 6, and 4 combination 4 is hopefully 1. Otherwise, that warm-up was absolutely for nothing. Anyway, but go ahead and see what you get for these 2 and check in with me in the next video.